So hello everybody. A warm welcome to our last session of the Choose According to Your Needs of our series, where we like to give you the news about our instrumentation in the food and beverage industry. And what I can recognize in the same way than the days before, we have still a number of participants from globally all over the world, and still from Asia. That means I have to say good morning, good afternoon, good night, and good very late night. Thank you for your interest again, and that you keep being with us. That makes us happy. Today we like to talk about Choose According to Your Needs for the liquid analysis. But before we start, I like to introduce for the newcomers how the system is working. So you can change this here. Whenever you have a question, please put the question directly in the questions box. So we will answer the questions then either directly online here, or we keep it until the very end. At the very end, we will have the Q&A, a question and answer session. And then we will go through all the questions there. And in case there are too many questions and we're running out of time, don't worry about this. Then we will go in contact with you via email, and we will come to you either directly us or from the organization local to you. Then we have the handout area. So we already uploaded the presentation material, and you can download this presentation material. If you are interested in that material, please do it right now, because later on when we close the session, you might not come to this area again. So use this hour now to download the material if you have any interest on that. And then of course, all the session will be recorded. This is the advantage for you. You can see this later on again, if you like to see it again, but you are also free to give this to your colleagues. So if you have someone where you have the feeling, wow, this was a great seminar, and others should see this as well. So you will get an information maybe within 2 days with a link, so you can share the link with your colleagues. No problem with that. Yeah, who are the presenters of today? This is me. My name is Matthias Schützeberg. I'm the Industry Development Manager for the food and beverage industry in the Endress+Hauser group, here in Group Services in Switzerland. But today I'm not the presenter. Today I am the moderator, taking a little bit care on the technique behind. The presentation will be done as the other ones with our specialists from the production center. So this is Maria Florencia and Dr. Michael Weiss, the specialists for the analytical instruments. I will not say more. I give over to you guys. Thank you for your presentation, and the floor is yours. Thank you.
Sorry, typical problem in these times, the microphone was off. Hi all, thanks for participating. I'm Maria Florencia Perez Lippi, Latin name because I come from Argentina. Since 11 years, I work in liquid analysis with Endress+Hauser. The first 3 years, I was working as product manager in Argentina. And then I moved here to Germany to the factory of liquid analysis. And since then, I'm an area manager of a region of the world. And I work together with Michael Weiss with a focus in the food and beverage industry. And now, Michael, if you want to introduce yourself.
Perfect. Hey, thank you very much. So also a very warm welcome from my side. So as you can read, my name is Michael. I'm with Endress+Hauser since 16 years. Had several positions so far, and my actual position is working as an industry manager for food and beverage, and I'm happy to support Flor. So thank you very much for giving me the chance, and then I hand over back to you, Flor. Thank you.
Perfect. So I will start with the presentation now. We will have an introduction first on how is our factory. Then after we will discuss about parameters and portfolio. After that, Michael will share with us some application examples. And last but not least, we will cover utilities, and in the end, a small sum up of what we shared today. So going to the introduction. So the liquid analysis part of ENH, the headquarters is located in Gerlingen, that is here where I'm working now. There we have research and development, also the management is here, and we make mainly the electronics assemblies and, for example, the samplers and the analyzers. Worldwide, so we were in 1970 founded, and we are worldwide more than 1,000 employees. Here in Germany, we have also two sites. One is in Waldheim. They are mainly the production of sensors, of the pH sensors, of the conductivity sensors, of the chlorine sensors, and they have also research and development there. And in Groß-Umstadt, close to Frankfurt, we have the production of our solutions. Then I will explain what is that. Then in China, we have a production site that is mainly focused in the Chinese market because of the certificates and all what we need there. And then in California, we have another type of production that is the production of the optical sensors. Also, we produce there some sensors. Those sensors are especially for the American market, the American continent market. There we also have research and development, and it's really oriented to these optical sensors. So mainly what we have is in different parts of the world where this specific knowledge for this product is where we have the factory. Now talking about the industries, as we said, today our focus is choosing according to your needs in food and beverage, but we have, as ENH, 7 focus industries, and we serve them all. For that is that we produce more than 7,000 transmitters per year, for example, 15,000 assemblies, that is what you see there, where inside we have the sensors that we produce more than 400,000 per year. It's important to also to share with you that we are leaders in pH sensors and also in the food and beverage industry in conductivity. The liquid analytical line is quite wide. We offer more than 30 different parameters, and this slide is more or less for you to have a size of the different types of sensors that we offer, like in pH, ORP, ion selection sensors to measure nitrates and ammonia, for example. Then the process photometers that Michael will give you really good examples after conductivity, dissolved oxygen. And then we have the analyzers that you see below. The big difference between the analyzers and the sensors are the analyzers are, they need for that parameter, we need to add a reagent, and that is what the analyzer doing itself. And for the sensors, you don't need that. And additionally, we have the samplers, and in our case, the samplers are like monitoring stations, because you can connect all these sensors to the sampler, and then the sampler can take samples by time or by parameter. Now going to the solutions, as I told you, we have a site that is producing our solutions. Our solutions mainly could be panels or even containers, where we have all the parameters that the customer needs in one place, and you just need to connect inlet and outlet. If it's a panel or if it's a container, it's exactly the same. And then you will have the whole solution and all what you need done in one place. So how are we present in food and beverage? Basically, the process is what we always speak about. So in the process, logically, we give you support to control and optimize your process with our sensors. Also in the cleaning and sterilization processes, and last but not least is the most important part, in inline quality monitoring. In inline quality monitoring, we support you to measure, not only to have the precise measurement and to have the correct product, but also because of product safety. That is one important topic in food and beverage. But additionally, what is important are the utilities, what's coming inside and what's going outside. So from what's coming inside, the water for the food and beverage industry is really a key raw material, because you use it for the production, and that's why it needs to have a specific characteristics to be able to be used in the food. And then the raw materials, normally we need to make analysis in those in order to use them. And what is coming out, the product as an end product, to release those products, we always need a quality analysis. And then in what is water treatment, in the wastewater, because of the food, as it has a lot of organic compounds, the wastewater normally is really loaded, and that's why it's so important, this treatment, before we deliver it to the sea or to any water receiver. Now, talking of what we have as portfolio, especially for food and bev, as I said, we have 7 focus industries, and for each of them, we deliver fit for purpose instruments with all what is needed in each of the industries. In food and beverage, we offer pH, conductivity, dissolved oxygen. The process photometers, we will see that they measure really different types of things like color, concentration of yeast, phase separation, turbidity. And then we have the assemblies, and the assemblies are the ones that I put the sensor inside, and they are our connection to the process. Why are they so important? Because in food, we need to have specific certifications and also a specific design for us to ensure cleanability and a lot of things. So we have special certificates for the food and beverage industries. And then here on the top, you see our transmitters. All these sensors, you connect them to the transmitters, and they are the one where you get the information from. And we have the different types of transmitters depending on the needs on your installation. But what is important is that each of these transmitters is recognized in all our sensors, so you don't need to have one transmitter for each sensor. Additionally, what we have are tools, like for example, a software that is in this computer, where you can use this software to calibrate the sensors or to also make measurements with the sensors. And then we have this small new transmitter that is a portable one, and that, for example, you can make samples and then perhaps comparing the process to a value of the process, or even, for example, in the wastewater treatment plant, if I want to have a sample measurement of the pH, I could do it also with this portable sensor. But also I can use that to calibrate the sensors. And here what we have are the things that we use for commissioning, maintenance, or calibration. For example, the buffers that we use to make the calibration of the pH sensors. On the right side, you will see the solutions that are specifically developed for the food and beverage industry, like this one, that is a solution that what it's doing is taking out the pH sensor from the process, cleaning the pH sensor, and then calibrating the pH sensor, and then putting it again. So it's for very high precision, and also to have an independence of the maintenance in this measuring point. Then for the utilities, also we have all the sensors needed for example, in the wastewater to be able to control and monitor this wastewater, and additionally for the water in order to know which quality it has before we use it in the process. Here are the samplers. That is what I spoke in the beginning, that they take samples per time, but additionally we can connect the sensors and then use that in order to, for example, get to know why the organic load was too high, because then we take the sample and we can make a special analysis to know which was the reason of this value. Now, in these times that the digitalization is so important, we will speak about something that ENH developed more or less 15 years ago, and was the digitalization of the value that I measure. This started with pH, because the pH is being measured in millivolts, and with these millivolts we enter to an equation that is giving us the pH. When these millivolts are 0, so when I don't have current, what it happens is that I have pH 7. So in the case in the installation that the cable was cut, or that the connection between the sensor and the transmitter, that is this cable, for example, because of humidity, is corroded, and then we don't have any current, then I would measure also 7. So what Endress+Hauser did a long time ago was to create this MemoSense protocol. And what it does is that in the side of the sensor, I'm measuring in millivolts, and then the signal is transformed to digital value, and then it's transmitted to the cable, that now I don't need a special cable, it's just a digital cable, and then it goes to a transmitter. This allows the installation to be completely independent of the measuring point. So what I need to calibrate is just the sensor, because the whole rest is digital. How it does that, if you see in the image, you have here a coil. This coil is this one in the sensor, and this coil is inducting a current that is transmitted to the cable the information. And then I have on the side of the cable another coil that is this one small, that is also inducting a current for the sensor to have enough energy to work. But if you see in none of the sides, you have any metal contact, and that is what is for the water or humid environment, or whenever you clean with water directly, the sensor has no problem because it has no metal connections. And if you have any problem in the connection between the sensor and the cable, what you will receive is just a signal that it says the sensor is not connected, but you won't receive any value. Additionally, in the sensor side, you have a chip, and this memory chip, because now what we have is not anymore MemoSense, it's MemoSense 2.0. In this chip, you have the 8 last calibrations and all the information of the sensor. So in the sensor head, I can connect my sensor wherever, not only in the transmitter, but also in the rest of the things that I showed you now, and access directly to the information. So I could see when it was calibrated, the last 8 times, the last 8 results. I can see, okay, last time I calibrated 3 weeks ago, so perhaps I should do the calibration again. Also, I have how many hours was working, when was installed, how many hours was working even in higher temperatures as it should. And that gives us a lot of flexibility. This sensor can be calibrated anywhere, not necessarily in the process. And then I can bring the calibrated sensor to the process, take the other one, put this one to measure, and the other one, I calibrate that sensor whenever I have time. And that allows us to have a high availability of the measuring point, and also to make the calibration in a comfortable environment, let's say. So thanks to MemoSense, again, I will have the same problem of today. Sorry for this, but I will show you the screen. Yeah, now can you see it? So thanks to MemoSense, what we have is that you can use the same sensor. I will use another sensor, so this, that is exactly for food. You can use the same sensor everywhere. You can have this sensor measuring in the process. Let's take as an example, mayonnaise. So it's measuring constantly in mayonnaise, and then there is a rule in the company that I need to take 2 samples and then measure them in the lab. I can have the same instrument measuring in the lab, for example, connected to the computer or connected to this portable transmitter. So then I go to the lab and I have another sensor in the lab, and in the lab I measure, but with the same sensor. And then the values are possible to be compared because I'm using the same sensor in the process and in the lab. And basically, additionally, you have all these service tools that will support you in both places. So the idea is that we are together with you in the whole cycle of your measuring point. Sorry for this, but I don't know why I cannot present that slide. Now, Michael will share with us the different applications that you can have with the different parameters. So it's sometimes it's clearer when someone is telling us an example instead of just speaking about technology as I did. So thanks a lot, Michael, for that.
Michael, can I quickly jump in and use this turn over to you to
you
ask
are the moderator. What? You are the moderator, so
I just do it. Huh?
yeah.
Yeah, I would like to ask you, dear customers, did you know about MemoSense before this session? Please just rate this yes or no. We got a little bit of feeling about, yeah, is it worth to talk about, or do you know it already? I see the ratio is even better than today morning. I'll give you some more seconds. Seems to be gets half. Okay, I close it, I share it with you. So 55% says yes, 45 says no, so it's half. That means at least half of you got now a new very nice information about this MemoSense. Really think about, and if you'd like to know more, you will see now with Michael's presentation that this is a good thing. So sorry for that, Michael. Now floor is yours again. Jump out.
Perfect.
And yes.
Very good. So thank you very much, Flor. Wonderful introduction. And Matthias, so you see at least more than 50% no MemoSense. Now we come to a couple of use cases and examples is where the sensors are used in the hygienic process. And you see here for the pH, which is a very important parameter, okay? So we have several applications. And one is to measure the product quality, and that is for examples like mayonnaise, ketchup, mustard, starch, marmalade, tomato sauce, edible oils, and so on. This is where very often is the product quality really depends on the pH value. Then, as well as this, we have the fermentation processes. Typical examples are here from dairy products or simply yogurts. And pH is also very important, is for the quality control during receiving of raw materials. Here, as an example, is shown milk. So that means we all know that if milk is not good any longer, it becomes sour. So that means we have lactic acid which is formed, and that means you have to react. That can be seen directly with the pH value. And of course, it is important is for the release of products is to ensure a certain shelf life and good taste. Yeah. Furthermore, we see that for the process optimization, so that other different use cases, as Flor has mentioned formally in her introduction. In the beginning, maybe just one back you see on the left side the different sensors. That means this is starting on the upper right. You see the typical glass electrodes, which you might know from the laboratory and so on. Floor is very good already. You see as well as then if we go a little bit further left upper, that means if glass is not allowed in the process, and that is what we see very often in food and beverages, then we have here an ISFAT sensor, which Floor is placing to the camera. Yeah, and beside that if you look at the lower left part, we have here an enamel part. And to the right part is that this is what Flor introduced. That means that is a completely fully automated system is where you can retract the sensor during the running process, is do cleaning, do even recalibrations of the sensor, sterilize it and bring it back into the running process. Perfect. Now we come to a few examples, and that is shown here for mayonnaise and for ketchup. And here pH is really important. This is first of all, this is for the shelf life, but as well as is for the taste of the product itself. So that means you need to be in very small limitations that you get the ideal product quality and product safety out of it. The challenge with these products is first of all, this is a very high viscosity. And then as well as is the high fat content in mayonnaise, and we have a very high sugar content in ketchup as well. And so that are typically is this two sensors which come into use in these parts. This is, and that is on one is the ISFAT sensor. That means this is when glass is not allowed. So if you can use ceramics, is then on the right side is we have our CPS 341D, is that is the enamel. And here you see is this all the yellow part in the lower end is this, that is the pH sensitive part. You see a very huge surface which gives you a very good measurement. This is even under these conditions with a high viscosity part. Good. As a second example, we want to talk about a little bit dairy products, and here is an example from a pH measurement. This is for dairy cultures. And that is when they start the fermentation, is they need different bacteria to start the cultivation. And besides the temperature, which has a very high and important parameter, but beside that, even pH is very important. And you see it in the graphic on the right at the bottom. The blue dotted line, that is the dependency is this of the formation of acetaldehyde at a certain pH value. And acetaldehyde is the most important component is this, which has an influence on which bacteria will survive and how active they will be. And that needs to be adjusted very precisely is this with the pH value. On the upper right, you see it in the process. Yeah. So that means is for this customer, it was very important is to have a continuous quality assurance. That means directly inline, that they can reduce the sampling. Very important, since that was very close to their final product, they said there shouldn't be any glass in my product or in my process. So that means they used here the ISFAT sensor. They have a very wet environment, so the MemoSense technology, so Flor explained it perfectly, is that means you don't have to fear anything since we don't have any contacts any longer. And beside that, for this customer, it was important is because they were audited a couple of times, is that they have a really good proof of their documentation. And Flor introduced our memo-based software earlier. That means you see it here on the right side in the laboratory is they also had a small station is where they could calibrate the sensors from the process and as well as do some measurements as sample measurements. Then we come to one further example, and on the right side is you wouldn't guess that that is coming from the food industry, but that is a typical sugar mill. Yeah, so that is good, like it works. And here the pH measurement is very important during the carbonization process. Yeah, because at that part is to remove now some inorganic and some organic contaminants. They add some lime and they add CO2. And of course, this is both of the components have an impact on the pH value. That means this is with the lime, it is going up, and with the CO2, it forms the acid and then going down, so you can adjust it. And that is important, is that you get the right sugar to avoid that you form the inert sugar. Good. Everything is good, Flor. So that means this is here. The challenge is whenever you have seen, let's say, this is one of these sugar mills, that means that is really sticky. Yeah, this molasses, that means it is warm. Yeah, and all the sugar molasses sticks to the wall. You see it on the picture on the left side at the bottom. That is a picture from inside the vessel. And you see already is there the whole molasses, but the sensor is free. And the reason for that is because they use the fully automated system. That means regularly they remove the sensor, they clean it with water. And that is why you see is that the sensor is still working and not clogged with the molasses, so that it still can be used. This is during the whole season. So that were a few examples of the different pH measurements. And now we come to conductivity. And again, here is this, I think the motto is choose according to your needs. That means here we can really provide different type of sensors and instruments. If we start at the upper right, so Flor, this time I'm faster. So that is a sensor, that is an inductive sensor. Yeah. And that is the main used sensor in the food industry, because as you can see on the right side, that is an inductive sensor, and that covers a broad measuring range and very high concentrations. That means you need it really if you want to measure higher concentration of salts, acids, cleaning agents, and so on. So that means then if you look a little bit left, that is a compact unit. That means this is for customers who say, okay, I don't want to have a separate transmitter. I want to have directly a head transmitter. We have the SmartX solution is where the sensor and the transmitter comes in one instrument. Then go down on the right side is we see the CLS16D, which is a 2-electrode sensor. And that is very often used. This is in water application where you have to measure low values. So then we come to the 4-pole electrode sensors. And this is contacting and this is used. This is if you want to measure a broad range, that means a little bit in the low range, but as well as at higher values. And if you want to measure is in very small line sizes, because that has a 12mm design at the tip, and so you can introduce it in even the smallest pipes. So completed is our portfolio for conductivity with the CLD18. And that is then now available as well with IO-Link. So that is, we just launched it last month. That means that is the first instrument is from the liquid analysis, is the first parameter, is this conductivity now available with IO-Link. This is for a very easy integration into the digital world over the IO-Link masters. Good. Now we come to a couple of examples, and the first one is then a CIP plant. You see the typical layout with the different vessels for the acid, caustic, and the water. And typically you have now the first sensors installed is in the vessels to adjust the concentration of the cleaning solutions. That means this is here, everything is added. The second sensors is now in the return line. That means this is the solutions go into the process, the cleaning is done, and then they are returned. And here the aim of the sensor is to make a phase separation to say what is the concentration of the cleaning solution, can we reuse it, or do we have to go to drain? On the next slide is this, you see a couple of pictures of the installation. That is for the concentration directly in the tanks for the CIP agents. And you see the different, in the upper right one, you see the different vessels. The sensors are installed from the bottom. And here is this, you adjust the acid and the base concentration in the tanks. That means here you need a very accurate measurement. This is because that has an impact. Now is a cleaning agent you bring to your process for the cleaning, is the concentration correct for the good cleaning purpose? If you add too low concentration, the cleaning won't be very good. If you add too much cleaning agents, you waste a lot of money. So that means it is important at that stage to have a very accurate measurement, what you have with the CLS54D. The second application is now in the return line when it is mainly the phase separation. Here you see a couple of examples, and here you see the compact units. That means here the customer decided not to combine all the sensors into one transmitter. Here they said we want to have one transmitter directly for each of the sensors and directly get the reading on place. So that means this is here, that is for the phase separation, is for everyone is coming back. And here it is important to have a fast response time, of course, to reduce losses and of course to reduce the energy consumption. Good. With the next, then we come to the next parameter, and that is the dissolved oxygen. If we start with the applications, typically is this you have with oxygen is this two different purposes. The first one is to measure the concentration of oxygen at a certain level, is to do like fermentation processes or to do the yeast propagation. That means here you have to ensure that your microorganisms get enough oxygen to breathe. On the other side is this, we have the applications where you want to measure the absence of oxygen. And that means that are the initization processes, or it could be for the fillers where we want to measure the absence of oxygen. And as an example as well, the degassing of juices. Yeah. Here, Endress+Hauser offers two different types of sensors. Faster floor, so that is a typical oxygen sensor, the optical one. And you see we have as well two sensors, and the reason for that is there are two technologies to measure dissolved oxygens, and both are established in the market. On the left side, you see our COS22D, which is an amperometric sensor. That means the measuring principle is as well on the left side at the bottom. And then on the right side, you see the MemoSense COS81D, which is an optical sensor. I personally prefer the optical sensor because the maintenance is less and so on, but there are reasons for both technologies to make it easy for customers, because we see several standards at customers. For us, we will just adapt according to your needs. That means we provide both of the sensors to meet the requirements. So a few examples. That means the first example, which will be shown on the next slide, that is the oxygen measurement in the yeast fermentation. And that is, as mentioned earlier, here it is important if we want to feed the yeast, we add molasses, a couple of other nutrients, and then it is very important that they have enough oxygen to start the conversion processes. Yeah, and to optimize now the concentration of the oxygen they measure directly the concentration at the inlet. And of course, since adding the oxygen creates a lot of energy, by using that sensor and installing it, they really could reduce the energy consumption by 5% just by installing the sensor in the inlet. So the second example is then the oxygen measurement in juices. In fact, here, typically this customer want to measure the absence of oxygen, because if you have oxygen in juices, they typically react with the different ingredients, like vitamins, like the aldehydes, which are important for the taste. And that means the content of oxygen, if you have too much in it, that has an impact on the taste, so the quality. And beside that as well to the shelf life, yeah, because it destroys the different ingredients. And that is the reason that very often these juices are even degassed, and then the oxygen is controlled before and after this degassing processes. So that means to control here the quality of the juices the oxygen measurement would be important. So Flora, then we come to the next parameter, which are the process photometers. And we have here a lot of different type of applications, and of course as well sensors, because according to the different application needs, we can provide the right instruments. And that are typical thing. If we start from the application, then the milk detection in CIP solutions or phase separation, we have our OUS AF11, which is on the left side. Yeah, a very nice sensor which works completely without glass. So that means this is no problem is to have glass in the process. Then we have on the right side at the top is this, you see our fermentation probes, the OUS PT66, which measures the concentration of the cells or of the biomass. Then at the lower left, we have the color sensor. That means here we have typical requirements. This is for the color measurement as well as is for the reference. Yeah, that means to compensate for any changes. Yeah, that means that is all implemented into our color sensor is to have here a very high and accurate reading. So, and then the last sensor here, that is a turbidity sensor on the right at the bottom is, and here we control the clarity and of a product, and we can control the filtration steps or even the separation steps in a centrifuge. So that is when we come to a few examples. You see already installed here a sensor for the phase separation between milk and water. The special thing here is very often is in dairies is you have a very high number of different type of products. And of course, if you all produce them, is you need intermediate cleaning steps, yeah, that the pipes are cleaned. So, and of course, this is you can control this phase separation by conductivity as well. On the upper right, you see the graph where the conductivity is a blue line. Yeah, you see a different, of course, this is between water and milk, but it is not very, very accurate in this case. Yeah, that means is you can do a separation, but if you want to do a really early detection, is then an optical sensor would be better because you see here, water has no absorbance, milk has a lot of sorbents. That means this is you already can detect traces, get a very early detection of product losses, so reduce the cost, as well as for the wastewater treatment, because if you have a dairy product in your wastewater stream, you pay a lot of money because you have a high organic load and you have to treat it. And the other part is if you see that you have products in there, is you can even reuse that. Yeah, so take it out of these washing pushes. That is a typical, they call it the cleaning water. Good. The next slide shows then is this a setup, how it is done. You know the Cip plant from before. So if we go now into a dairy, we start again, this is with the sensors is in the vessel for conductivity. Perfect. So, and then of course, this is, you remember, we have in the return line, we have the conductivities to measure the concentration of the solutions. That means for the salts and for the caustic and acid, that is still the conductivity. But now we can also add, this is our OUS AF11. And the nice part is this now that you can connect all these sensors only to one transmitter, the CM44P is this, and to operate all of them is to get the full control of these CIP systems. The next application is then a typical color and turbidity measurement. That is for edible oil, where during the production of that is we need a lot of bleaching. Yeah, that means we have some contaminants during the pressing of the seeds and so on, which can go in. So that needs to be removed and controlled. That means by that we can control the color. Besides that, the color gives us always an indication what is the concentration of the chlorophyll. That means we are coming here from plants where chlorophyll is still in. And that means this is as well for the quality control. You can here check whether it is working well. So, and by using that, that means looking at the color and the clarity, we have here really improved control of the taste and the color. And beside that you can guarantee that you have a steady quality, because if you have changes over time, you directly will detect that with these optical instruments. Good. Then, of course, as a German, I always have to talk about beer. And the next part is here that is a color measurement in beer. You see in the scale in the middle, there are a lot of different beers available, starting from the light ones like a pale lager, or you see the German Pilsner is even mentioned there with an EBC value of around 5. But I think we all know these darker beers like the stouts or the dark lagers, so which have a completely different color. But the most important part is here is of course that the different charges and lots always have the same color. And that can be controlled directly inline with a color sensor. You see that in the upper right picture. We also controlled that in a loading truck. Is this where the beer was brought to a different part? That is in a lower part. Even there, it was really installed on the truck to see that the right product is filled in. So here, that was a really fast detection. This is to see whether we have the right product and also used for the identification. Good, and then we come to the combination of a couple of parameters. That is the beauty of having a modular system and a complete liquid platform. You see here is for bottling and filling. Typically, this is 4 parameters are interesting. And first of all, it is a conductivity measurement to ensure that you don't have any contaminants in or any leftovers from CIP cleaning agents. The CIP value, we heard that earlier, that is really important for the quality, the taste, and the shelf life. Yeah, that means very often they try to reach a certain number. Then the DO is important, the absence of DO, that you don't have any oxidation in the product. And as a last parameter is sometimes they even add the color sensor to ensure the quality control and to see this for the product identification. All the sensors can be connected to one liquid analysis to get the results out of it. And we have one more example. This is where we see the combination of instruments. That is the ICUMSA color measurement and the Brix measurement, and that is in the syrup dosing. That means this is a concentrate, the syrup is coming, then it is diluted with water, a couple of other ingredients, everything is mixed, and then it goes to the filler. That means now it is important because the raw material, that means the syrup can really have different qualities depending on where it's coming from and so on. So it is very important is now to measure the ICUMSA, which is a color value, but as well based on the sugar content. And you see the ICUMSA color is defined in the lower equation where you have the AU, which is the absorbance value. That means this is a color value. So then multiply this is with a constant, which is 100,000, and then you have to divide it by the density and by the Brix value. And that is now the nice point is that the pro mass, that means out of the Coriolis principle, we can also use that to measure the density and the Brix. That is going over the 4 to 20 milliampere output is directly into the liquid line, and there it is calculated with the mass functions we can do the direct equation putting in that. And by that we could now ensure a repeatable quality, improve again the taste and appearance. And whenever something happened in the raw materials or during the filling we directly can detect it if there are any changes. Good. With that, I think we have a couple of examples about the different hygienic processes. And now, Flor, I hand over again to you. Is this when we talk a little bit about the utilities as well?
Thanks a lot, Michael. Yeah, so closing today's topics, I will speak about utilities. As I said in the beginning, in the food and beverage industry, it's really important, the processed water, but also for the environment. For the food and beverage industry, it's important the control of the wastewater. So talking about processed water monitoring, the main parameters that we see globally that are being monitored are disinfection in general, because in some cases we need to disinfect the water that is, for example, taken from a lake or from a well to be treated and then used for the food production. So then for there we have chlorine dioxide that we measure as chlorine dioxide, free chlorine, and also ozone. We measure conductivity, turbidity, pH, and in the case needed with the analyzers, hardness, iron, and chrome and aluminum. What is important is that till today we have already really good and a lot of experience in the, for example, in soft drinks production or in beer production, that they are monitoring the water with our panels. And for example, in the production of coffee, in the production of cheese, also it's really important the monitoring of the values of this processed water. This sensor that you see here on the top left is our turbidity sensor. That is the only turbidity sensor in the market that can measure directly in the pipe. As also is the trend, the water scarcity in the world, the important thing of this sensor is that you can measure online, you don't need to take out sample and also to waste water for measuring turbidity. This, for example, on the left is an example in the beer industry where we are measuring turbidity, conductivity, free chlorine and pH in the processed water. And this on the left is a panel that is a typical example for a disinfection measurement. Also, now we have in some parts of the world cold CIP instead of the typical CIP that we were used until today. And our disinfection sensor cover also this high range for measuring disinfection. Then in the cases of steam production, so in the plants that they need steam in the production, we have the panels that are made for that, since we need to put down pressure and temperature in order to be able to measure with the sensors. So then for that, we have special panels with first a sample preparation and then all the parameters that are needed to measure. For example, in the sugar industry, the steam is really used, and in those cases, we have those panels installed. Then talking about the wastewater, 80% of the instrumentation needed in a wastewater treatment plant is an analytical instrument. And we have all the parameters that are needed for that. For example, the analyzer for COD, that is the chemical oxygen demand, for TOC. In the case of the food industry, where you have sometimes a lot of fat, normally the customers are using something that is called DAF. And before and after the DAF, it's really important to measure the organic load to see which is the performance of this DAF. But additionally, pH, dissolved oxygen, conductivity. So we have all you need to cover all the steps of the wastewater treatment plant. So taking as a general view of a wastewater treatment plant, what we have is that in the inlet, normally we measure pH, not only to neutralize, but also to support the flocculation process. And then conductivity, organic load, to know how much organic load is entering, and in the case needed, to put that in a buffer tank. But additionally here, and really important, some food and beverage customers, they have a sampler in the inlet, because as normally we have multi-product sites. So for example, a site can produce mayonnaise in one line, ketchup in another line, then perhaps they produce soup in another line. And whenever they have a high organic load, they don't know from which of all the lines. So in order to know what to do and to go backward and say, okay, we should change this, this, and that, they have a sampler, and whenever, for example, the organic load is too high, they take a sample, and then they can analyze from which of all the lines came this sample. So in the inlet, it's important, for example, to use a sampler. And then in the rest of the wastewater treatment plant, you will find all the parameters needed, and we can support you there also. So going now to the conclusion, we support you in choosing according to your needs in the industry compliance and product safety. So all the products that you will use have the needed certificates for you to be always on the safe side and to measure with a safe product. Increase efficiency and reduce costs. For example, with MemoSense, we support you reducing stock, so you need just one transmitter for all the measurements. Also in efficiency, because the MemoSense is evaluating constantly the sensor and will support you through heartbeat to have a better maintenance and a smarter maintenance, and to have a good predictive maintenance. That this will allow you to have a precise measurements and also less time dedicated to the measuring point. Improve the quality monitoring, basically having the same technology everywhere in the lab and in the process, and you will have a better quality monitoring because you will be always comparing the same values. And last but not least, to optimize your utilities. As we said, processed water is really important in this industry, and also the wastewater to meet the legal requirements of the discharge. And for that, we have all the sensors you need. The last comment that I want to share with you is that last year we won again the Frost & Sullivan Award that declare us as the Global Liquid Analyzer Company of the Year. And that means this is a company that you don't apply for this award. Frost & Sullivan, they are evaluating the market for the companies that they sell the same type of instruments, and then they are giving the award to the best company. And that is what I wanted to share with you. So thanks a lot. And now, Matthias.
Yes, I'm here.
Hi, how are you?
Thank you both for this nice insight and these nice informations. I will make first myself now as a moderator. 1 second for. So the next question would be, Michael, are there some questions to answer?
Basically, one question is that we show that we can connect the sensor to a computer. If that is like that, well, I answer that. Yes, what we have is an interface that it's called. Yeah, Michael, you are the best. What is showing Michael there is the interface that you need to connect the sensor in the top, as I showed you in the beginning. So Michael has this side that is the cable, and then that is connected to the MemoLink, that is the black square, and that is connected directly to your computer through a USB port. You can connect to the computer, you can connect 4 sensors in the same time. So you could have 3 spaces for calibrating and 1 for measuring, or even to measure with the 4 of them. But you can do that, it's super flexible. And it's also plug and play. So when any sensor you connect, the computer will recognize the sensor. You don't need to select anything. It's just the parameter appear in there, and you start using it. I'm just checking. Well, basically, I think that's all, no?
So what is the code for the connector? I think that is for the MemoLink.
Ah, yes.
Oh.
Yeah, I need to check because it's a 5 million number. And so we need to check that, and then we will send it to you.
Absolutely correct. This is, I think you can find it even on our website. This is, but typically you see there is a order code number, and as Flor mentioned, is that it's done by there is no order code directly completely for it, but it can be purchased directly with under that. So MemoLink is the magic word.
So I think
yeah, I think there's one question during calibration. It is to inject the standard signal directly to the transmitter without sensors, or what is the best recommended, or together with sensor to be soaked in the standard buffer solution. That means it depends a little bit. Let's say this is on the parameter, to be honest, but the best part is always to have the sensor connected either to the transmitter or to the memo base. And then we have the different parts, like for pH, you have the standard solutions. The buffers is where you can do a 1-point calibration, 2-point calibration, or whatever is needed. For oxygen, it is completely different there. The hardest part is to make the 0 point. We have here a special 0 point gel. That means where you can introduce the sensor and it removes all the oxygen around that, and then you get a very stable 0 point. And so if you ask me, the best way is to calibrate then an oxygen sensor is in fact in air. Yeah, that means especially if you have an optical sensor, that is very easy to handle. Just have it in the air where you have very defined conditions if you know your pressure, yeah, and then you know exactly what is the concentration of oxygen. Yeah, good. I think that's it. So I see that this answers the questions. I think that were all the questions.
Yes, I think yes.
So that means, Flora, you can leave if you like, because the rest I can manage by myself. So you can head to your next meeting.
Thanks a lot. And thanks a lot to all for your attention. Thanks a lot, Matthias.
Yeah, thank you for your help and for your presentation. Yeah, for you, dear customers, how can we, when we stay here, how can we help you now to improve your processes? Of course, choose according to your needs, and this is what we like to give you with this series of seminars during this month. That you get a little bit of insight on the different instrumentation which help you on every part, on every measurement in your processes. So it doesn't matter if this is really an important safety factor or if it's just I like to know this values. It's a good to know the value. So we have the right instrument for all these applications. Whenever you have more questions, whenever you like to know something on addition, please go in contact with your local organization or check the website on www.endress.com. So there you will find as well a lot of information. And one of them is, for example, here the live webinars and the recordings. I put the link to the handout, so you can just use the link there, or you will find it when you enter the website. You will find it there. All the past seminars you will find there. But what you will find there as well, all the future seminars. And it's not only that we are doing these kind of marketing seminars, what we did in the last time. We very often doing technical seminars also for customers. So please check there if you find a seminar which maybe fits to your technical questions or technical daily works. There will be a lot of seminars as well. And don't forget that we have all the webinars which are recorded. They are open for you. So just go through and use the link and you can see all the past seminars we did for these kind of instruments for you. For example, if you missed the level or the pressure part at the beginning of last week, or the flow part, or the temperature part, these sessions are already there. Yeah, that's it from us. I would say thank you very much for your interest and for your time, for all of you, and especially for the Asian ones. So now I think now it's time to go to bed now. Thank you very much. Hope to see you in one of our next seminars. Hope we could give you a little bit more insight and answer some of the questions. Thank you. Enjoy the time. Stay healthy. Take care, and see you hopefully next time, maybe in your country. Thank you and goodbye.
Bye-bye. Bye-bye.